Dear students, this is Eswara Rao of Kintali, working as a PGT Mathematics in KV number 2, Port Blair, Andaman and Nicobar Islands. In this video, you are going to see what is a transpose of matrix, what is a symmetric matrix, what is a skew symmetric matrix, how to write every square matrix into a symmetric and a skew symmetric matrix, sum of a symmetric and a skew symmetric matrix, also what are matrix elementary transformations, and using matrix elementary transformation how to find out the inverse of a square matrix if exist. These all points you are going to see. I'm going to discuss these all points in this video. Yes, if you take a matrix A 1 2 3 4 1 2 something, some matrix I wrote on this paper. Now what is transpose of the matrix? Transpose of A. Transpose of A is denoted by A transpose or A dash. A transpose A dash. So transpose of the matrix is obtained by changing the rows as columns or rows as columns as rows. A transpose is equal to, given matrix is 1 2 3 as first row, you can write it as first column, 4 1 2 second row second column. This is A transpose. From this you understand that order of A is equal to 2 rows 3 columns. Then what is order of A transpose? 3 rows 2 columns. So you can say that if it is an m by n matrix, A is an m by n matrix, so A transpose order will be n by m. So because we are changing rows as columns or columns as rows. So then after this, what is a symmetric matrix? What is a symmetric matrix? Symmetric matrix means it should be A transpose is equal to A. If A transpose is equal to A, then matrix is called symmetric matrix. So what is A transpose is equal to A? It is possible, you should understand that it is possible only the matrix A is a square matrix, because matrix orders are changing. A is order 2 by 3, here A transpose is 3 by 2. They never be equal, we cannot compare. So that means A transpose and A should have same order, then only we can compare equal or not equal. To compare that, they must be a square matrix. So a square matrix said to be a symmetric matrix if A transpose is equal to A. Let us take an example. 2 3 4 2. Let us write what is A transpose here. 2 4 first row I wrote as first column, then 3 2, it is like this. So are these two are equal? No, not equal to A. So it is not symmetric. Let me take another example. 1 3 3 5. Let us write what is A transpose. A transpose is equal to 1 3 3 5. Same thing we got it. So it is a symmetric matrix. Similar way you can take any matrix of 3 by 3 order and you can find out A transpose. If 3 by 3 order you take and find A transpose, then if A transpose is equal to A, then you can say that it is a symmetric matrix. That is the symmetric matrix definition. So what is a skew symmetric matrix? Skew symmetric matrix. Look very carefully. If A transpose is equal to minus A, here also comparison was happened, so A must be a square matrix. If A transpose is equal to minus A, then that is called skew symmetric matrix. So in another words, I can say that if A transpose minus A is equal to 0, the matrix is called symmetric. A transpose plus A is equal to 0, not null matrix, then matrix is called skew symmetric matrix. In this way also we can define symmetric and skew symmetric matrices. So let us give an example. A is equal to 0 3 minus 3 0. Let us find out A transpose. It is 0 minus 3 3 0. Let us take minus common, then it is 0 3 minus 3 0. So it is equal to minus A. From this you can understand that A transpose is equal to minus A. A is skew symmetric matrix. So there is a particular property. You see that A is equal to 0 A B minus A 0 C minus B minus C 0, then it is always skew symmetric. You can find out the transpose of this matrix, then you get A transpose is equal to minus A. This is a skew symmetric matrix. For skew symmetric matrix there is a pattern actually. Diagonal elements must be 0. Diagonal elements must be 0. For a skew symmetric matrix, diagonal elements must be 0, and non-diagonal elements in the respective positions in the first row second column and second row first column elements are inverse to each other. A minus A, B minus B, C minus C. See the positions exactly. Those will be inverse to negative, additive inverse to each other. That means negative, one is negative of other, one is negative of other. So that is the skew symmetric matrix particular property. So in this symmetric matrix, A transpose is equal to A means every Aij will be equal to Aji. Aij will be equal to ith rows jth column will be equal to jth rows ith column element. But here ith rows jth column will be equal to minus Aji. So like this. In this like this. So like for example, if it is A11, A12, A13, A21, A22, A23, A31, A32, A33. So see this one, A12 and 21 are equal, 13 and 31 are equal, 23 and 32 are equal for symmetric. For skew symmetric, this 1 2 will be equal to minus of A21. These two are negative to each other, these two negative to each other, these two negative to each other. And diagonal elements are zeros for skew symmetrics. Non-diagonal elements will be like that property will be there. For a symmetric matrix, these will be any numbers, not a problem. But these two must be equal. So you are understanding it. That is about symmetric and skew symmetric matrix. Now let me explain about how to write a given square matrix as a sum of a symmetric and skew symmetric matrix. It is a very important concept. For a 2 marks you can expect this kind of questions. So like if you take any matrix A, you can write as a symmetric and skew, sum of a symmetric and skew symmetric matrix, like it is half into A plus A transpose plus half into A minus A transpose. Before I say this one is a first one is a symmetric matrix P, I can write this one is Q. If you take P plus Q, P is symmetric, Q is Q symmetric, I have to explain. So before that, let me explain about some properties of transpose of a matrix. If you take A transpose, whole transpose will be equal to A. That means 2 times you are interchanging rows and columns, means you will get the same matrix. And also K into A whole transpose is equal to K A transpose. This K is a constant here. And also A plus B whole transpose you can write as A transpose plus B transpose. I am going to use the sum of these properties for proving this symmetric and skew symmetric. Let me take P transpose, find out P transpose for this one. It is half into A plus A transpose whole transpose. It can be written as half into A transpose plus A transpose whole transpose is A. So this is nothing but P. So it is a symmetric matrix. Similar way, Q transpose, it is half into A minus A transpose whole transpose is equal to half into A transpose minus A. See that if I take minus common, I will get A minus A transpose. So this is equal to minus Q. So you can say that Q is skew symmetric matrix. That means if you are asked to find out, write the given matrix as sum of a symmetric and skew symmetric matrix. Let me give an example. A is equal to, example, write this matrix 2 3 5 7 into sum of a symmetric and skew symmetric matrix. First find out what is A transpose. In the first step it is 2 5 3 7. Then let us find out half into A plus A transpose is equal to half into A plus A transpose is 4 8 8 14, 4 8 8 14. So divide, then you get it is 2 4 4 7. Then this is P. And then Q is equal to half into A minus A transpose, which is equal to half into 2 minus 2 0, 3 minus 5 minus 2, 5 minus 3 2, 7 minus 7 0 is equal to take half divide 0 minus 1 1 0. So this is Q. Then you just write A is equal to sum of these two or not. Check it out. 2 plus 0 2, 4 minus 1 3, 4 plus 1 5, 7 plus 0 7. That means we got it. That means I can write A is equal to 2 4 4 7 plus 0 minus 1 1 0, hence found. This is we have expressed finally A as sum of a symmetric and a skew symmetric matrix. This is symmetric, this is skew symmetric. And if they ask you to write, you have to write like this. Otherwise, if they ask you to write and verify, means you should prove this is symmetric. P transpose is equal to P. Also Q transpose is equal to Q. You have to prove one more step you have to write. If they ask you to verify, write sum as a symmetric, sum of a this matrix as sum of a symmetric and skew symmetric, means just find out and leave it. And hence verify means you will have to verify. Same way for 3 by 3 matrix also you can do it. Every square matrix can be written as sum of a symmetric and skew symmetric matrix. Hope you understand this one also. Thank you. Now it is very important concept, matrix elementary transformations. It is a 6-mark model. We are going to get based on this in the board examinations. What is a matrix elementary transformation? If I take a matrix A is equal to 2 3 7 9, like I wanted to write C1 is equal to 1 by 3 C1, C2 is equal to 1 by 3 C2, column 2 I wanted to write as 1 by 3 C2. That means I am getting A is equal to, after affecting that and one more matrix I will get. So column 2 must be divided by 3. That is the intention. 1 3. That this is not equal to A, but I have got the matrix after doing like this 2 1 7 3. Like for example, if I wanted to effect an operation for this one as row 1 is equal to row 1 plus row 2, that means I wanted to change row 1, whatever I am writing on the left hand side with arrow mark now, that I am going to change as row 1 plus row 2. That means row 1 will be affected as row 1 plus row 2. That means row 1 I am going to write row 1 plus row 2. 2 plus 7, row 1 elements are 2 1, row 2 7 3. So 2 plus 7 how much? 9. 1 plus 3 how much? 4. So 7 3. This is the after applying the operation on this matrix I get this one. However, any matrix you take 3 4 1 2 0 5 3 2 5, I wanted to write row 3 is equal to row 3 minus row 1. Row 3 minus row 1. What I am going to get means I have to subtract all row 3 elements from, I have to subtract all row 1 elements from row 3. All row 1 elements from row 3 I have to subtract. What are the row 1 elements? 3 4 1 2 0 5. Then where I have to put, this is the changing one. Row 3 is going to change as row 3 minus row 1. Row 3 minus row 1, 3 minus 3 0. 2 minus 4 minus 2. 5 minus 1 4. Like that we are going to get. So also I wanted to write here one more operation for this. We can write interchange row 2 and row 3, double arrow. You observe this double arrow. Whenever this I have double arrow is there, means you are going to interchange the rows or columns. If I write C1 interchanges with C2, I have to interchange C1 and C2. Like that row 2 and row 3 I am going to interchange. Then I am getting 3 4 1 will be fixed, no change in that one, because we are not telling about anything row 1. Now row 2 and row 3 is going to interchange 0 minus 2 4 and 2 0 5. We get it 2 0 5. So carefully we have to do the operations. We will have to practice a lot on these operations to get perfect idea. But once you get idea on this topic, on these operations, you will not forget. This is very easy to understand if you are carefully listening, and also it is very important model. You are going to get a 6-mark model based on this. Also see students, once again I will explain you about these operations because it is very important thing. Like by taking an example, let us take A is equal to 2 3 1 2, B is equal to 1 4 2 1. See, where is the use also I am going to explain along with the operations application. Now I wanted to take the product matrix as A into B. So after finding the product matrix as A into B, it is 2 3 1 2 1 4 2 1. Let me multiply. What I am going to get? 2 1 are 2 plus 6 8. 8 plus 3 11. 2 1 plus 4 5. 4 plus 2 6. Verify again. 4 8 plus 3 11. 2 plus 1 plus 4 5. 4 plus 2 6. This is the product matrix. That means when you multiply 2 3 1 2 with 1 4 2 1, you get the matrix 8 11 5 6. Now in this matrix elementary transformations, you have seen two kinds of operations, row operations and column operations. See, I have done two kinds of operations, row and column operations. Now this product matrix is there. For this product matrix, I wanted to apply a row operation. I wanted to write row 1 as row 1 plus row 2, or row 2 as row 2 plus row 1, whatever it is you do it. But here when you do a row 1 is equal to row 1 plus row 2, here will be a certain condition. You cannot apply this operation, particular operation, to all three matrices. Whatever you see here, all three matrices you cannot do that. Row 1 is equal to row 1 plus row 2 means when you are multiplying rows with columns, you are multiplying. That means first matrix rows, second matrix columns are multiplied. That means this row operation will be applied to the left side only to the first matrix. 2 plus 1 3, 3 plus 2 5, and second matrix there is no change. Now again product matrix will be affected with this one. Always the right side matrix will be affected for this one. Product matrix, row 1 is equal to row 1 plus row 2. So 8 plus 5 13, 11 plus 6 17, 5 6. Let us check now once again. 3 1s are 3 plus 5 2s are 10. 10 plus 3 13. 3 4s are 12 plus 5 1s are 5. 12 plus 5 17. 1 plus 4 5. 4 plus 2 6. Getting. Now for example, if you wanted to do C2 is 4 into C2 minus C1. What I am going to do? 4 into C2 minus C1. Otherwise, C2 is C2 minus 2C1 I wanted to do. C2 minus 2C1. We can do like this. This is column. Column operation must be applied. Rows are multiplied with columns. That means column operations will be applied for the second one. So, first one there is no change. Now, second one C2 I am changing. So, C2 I are changing means first column not changing. 4 minus 2. Kitna 4 minus 2 is? 2. 1 minus 4 minus 3. Now here also what happened? C2 will be changing as C2 minus 2. 17 minus 26. 6 minus 10. Now let us verify these two. 3 ones are 3 plus 10, 13. 6 minus 15 minus 9. 1 plus 4, 5. 2 minus 6 minus 4. Yes, we got it. That means row operations will be applied. Row operation, once again see. C2 is C2 minus 2C1 was applied. C2 is C2 minus 2C1 was applied. So that means this will be affected as 4 minus 2, 2. 1 minus 4 minus 3. This is also 17 minus 26 minus 9. 6 minus 10 minus 4. So I have to multiply C2 minus 2C1. That means first column multiplied by 2 and subtracted from C2. That way you have to do it. Now let us verify. 3 ones are 3 plus 10, 13. 6 minus 15 minus 9. 1 plus 4, 5. 2 minus 6 minus 4. I hope you got it. Why do we row operations? Why do we column operations? Row operations will be, if you wanted to do row operations for a product, row operations will be done for the first matrix. If you wanted to column operation for a product, so column operation for the second matrix. But product matrix will be affected in both the cases. This is the important cheese you need to remember. So this will be used, these row column operations will be used to find out the inverse of the matrix. How to find out the inverse of the matrix? By using this elementary transformation of the matrices, we will see now. Finding inverse of the matrix using elementary transformations if exist. How to find out inverse? For example, let me take A is equal to 2, 3, 2, 3, 4, 7. 2, 3, 4, 7. A is equal to. So first write, see what is an inverse actually. If you get product is equal to A, B is equal to B, A is equal to identity matrix, then B is called inverse of A. B is called inverse of A. But whenever you multiply identity matrix with A, then you get always A. So there are two ways of finding inverse. One is by row operations. Another one is by column operations. Only two ways. Row by column operations. How to find out the matrix inverse? By using row operations. So let me write A is equal to IA first. What is A? 2, 3, 4, 7. I 1, 0, 0, 1 into A. Now see, right side it is product, left side a matrix 2, 3, 4, 7 is there. Now if I get AB equal to BA is equal to I, the product becomes I. If this become I, then this is called inverse of A. The first matrix will be changed by using only row operations. So now, but I have to change this matrix as identity matrix. That means this one becomes 0, this one becomes 0. I need to make these two become zeros, these two are ones. So first I will concentrate on making zeros. How to make this 4 as 0? Where is this in the second row? So row 2 is equal to 4 means row 2 minus 2R1. Why do apply this operation only? Because row 2 is equal to row 2, 4 minus 2R1, 2 2s are 4, that becomes 0. That means try to understand. We need 1 0 0 1 locations. This one zeros I needed on the product matrix. So when I need this 1 0 0, this one I want 0, this one I want 0, this two I wanted 1. First I will try to concentrate on zeros to get how to get the zeros. R2 is R2 minus 2R1. When I do that, I will get this is 0. Let me do R2 is R2 minus 2R1. 2, 3, 4 minus 4, 0. 7 minus 6 because I multiplied 2, 1. 1, 0. Same, it will be affected here also. 0 minus 2 because 2 multiplied and subtracted. 1 minus 2, zeros are 0, 1. Done. Now see, this is 3 now. I wanted to make this is 0. So to do that, what we will do? R1. This is in R1 now. this is 0. R1 is equal to R1 minus 3R2. Because why 2 multiply 3? 3 1 are 3. 3 minus 3, 0. So, 2 minus 0, 0. 3 minus 3, 0. 0, 1 is equal to 1 plus 6, 7. 0 minus 3. Because minus 3 multiplied and added. Or 3 multiplied and subtracted. Into A. Into A. So, what operation I applied here? What operation I applied here? R1 is R1 minus 3R1. R1 is R1 minus 3R1. So it is 2 minus 0, 0. The 3 minus 3 1 are 3, 0. 1 plus 6. Because minus 3 into minus 2 plus 6. 1 plus 6, 7. 0 minus 3 minus 3. So minus 2, 1 is fixed like this. Now next one is what I got here. Once again let me write 2, 0, 0, 1 is into here. But left side we needed identity matrix. So, but it is 1, 0, 0, 1. But we got 2. So, row 1 divided by 2. That means row 1 multiplied by half. Then I get 1, 0, 0, 1. 1, 0, 0, 1 is equal to row 1 only. 7 by 2 minus 3 by 2. By 2 by 2. Minus 2, 1 into A. So, product of two matrices is an identity matrix. That means this is the inverse of A. Therefore, I can say that A inverse is equal to, A inverse is equal to 7 by 2 minus 3 by 2 minus 2, 1. If you have a doubt, multiply this and with A, you get 1, 0, 0, 1. This is the inverse of A. So, we can find out a 2 by 2 matrix inverse by using this method, by using row operations. Similar way, we can apply the column operations and we can find out. Let us see by column operations how to do. By column operations how to find out inverse of 2, 3, 4, 7. By column operations. By column operations means you should take the identity A is equal to AI. A is equal to AI. If by column operations you should take the identity A is equal to AI. What is A? Here A is 2, 3, 4, 7. So 2, 3, 4, 7 is equal to A into 1, 0, 0, 1. Because columns means second matrix will be affected. Now, I wanted this is 0, this is 0. When I want this is 0, first 3 I will take from here. Column 2, it is in column 2, is equal to 2 column 2 minus 3 column 1. 2 3s are 6, 3 2s are 6. 2 into column 2, 2 3s are 6. 3 into column 1, 3 2s are 6 minus 6, 0. Others will be changing as it. 2, 4. 6 minus 6, 0. Now 2 4s are 7, 2 7s are 14, minus 12, 2 is equal to A into 1, 0, 0 minus 3, because 0 minus 3 1s are 3, 0 minus 3, 2 1s are 2, minus 0, 2. Next, this one I wanted to make 0. To make this one is 0, it is in column 1 is equal to column 1 minus 2 column 2, because 2 2s are 4, 4 minus 4, 0. So it is column 1 2 minus 0 0, 4 minus 0, 4 minus 4 0, 2 is equal to A into, I get 1 plus 6 7, 0 minus 4 minus 4, then we get minus 3 2. Then what I have to do, I need to make 1 0 0 1 on the left side. So you do column 1 is 1 by 2 column 1, column 2 is 1 by 2 column 2. Then you get 1 0 0 1 on the left side. Right side 7 by 2 minus 2 minus 3 by 2 1. This is the inverse. Then what is the inverse of A by using column operations? So we got the same thing as we do by using row operations. We got using row operations we got 7 by 2 minus 3 by 2 minus 2 1. Using column operations 7 by 2 3 minus 3 by 2 minus 1. Both the cases we got the same answer. If you see the A inverse, I hope you understand this one, everyone. So, but for a 6 marker question, they are going to give you a 3 by 3 matrix to find out the inverse by using elementary operations. That is very important for this process. I will explain you very carefully. So please listen to this very carefully. If you take a 3 by 3 matrix, what is the process? See, for the row operations, you should take A is equal to IA. For the column operations, you should take A is equal to AI. most of the exams they are not mentioning by using row or by using column, but they are asking by using elementary transformations. Better to concentrate on only row operations. Most of the students will do by using row operations. If possible, you try to practice on column operations also, because both are tending to same situation. A is equal to A will be used for row operations, A is equal to AI will be used for column operations. To find out the inverse for a 3 by 3 matrix, if you take you. So when I write A is equal to IA, I should make A as identity and I will be some other matrix will be converted. That means here identity means what? These will be ones and these elements becomes zeros. The way I am circling, see, that is the anti-clockwise direction. In that way only we are going to make the operations. Like my operations are going to be, see, A11, A22, A33 will be like that. So this is my first operation to make A21 0. This is my second operation, then third operation, then fourth operation, then fifth operation, then sixth operation. These 6 operations first we apply to make these 6 elements zeros, then we concentrate on making ones. This is the way we do it. See, this is anti-clockwise direction. Then there will never get disturbance, but carefully you have to do the calculations. 1, 2, 3, 4, 5, 6 operations. So after the 6 operations on rows, then you make these ones. Then you will get the right hand side. This will be changed as inverse of A. So let us take one great example and let me explain this question. So main concentration on making these all zeros by using row operations. Let us take an example and do that. Finding inverse. Let me take an example. Obtain the inverse of the matrix using elementary operations. A is equal to the given matrix is 1 3 minus 2 minus 3 0 minus 5 minus 2 5 0. Now the process is making operation 1, operation 2, operation 3, operation 4, operation 5, operation 6. After that making ones. To make zeros, we do operation 1 to operation 6 with the help of the diagonal elements. We take the help of the diagonal elements, whatever they are. So first write A is equal to IA. This is for row operations. We take A is equal to IA. So what is the operation 1? First write A is equal to IA. Write 1 3 minus 2 minus 3 0 minus 5 2 5 0 is equal to the identity matrix into A. I am applying row 2 is row 2 plus 3R1. Why row 2 is row 2 plus 3R1? Because I needed, this is 0. What I needed? Minus 3, I wanted to make it as 0. This one I wanted 0. That is the reason minus 3 plus 3 will be 0. That's why 1 must be multiplied by 3. Row 2 is row 2 plus 3R1. Then I get same, all will be affected. These all row 2 elements will be affected and this row 2 elements also will be affected with the operation. So minus 3 plus 3 0. 0 plus 3 3s are 9. And minus 5 plus minus 6 is minus 11. Then 0 plus 3 3. 1 plus 0 0. 0 plus 0 0. Then we got it now. Now the next concentration on in this step you have to see in this one. Now next concentration you wanted to make 2 as 0. What do you wanted to make? 2 as 0. And you have to take diagonal element help only. You cannot take this one help. You have to take this one help. See, this is in row 1. So it is row 3 is row 3 minus 2R1. 2 minus 2 is 0. Similar way 5 minus 6 minus 1. 0 plus minus of minus plus 4 4. 0 minus 2 minus 2. 0 minus 0 0. 1 minus 0 0. Then you see that we need this one is 0. See the operations order, you see operation 1, operation 2, operation 3. 1, 2, 3. So then it is minus 1. It is 9. So you do multiply with row 3 is 9. 9 row 3 plus row 2. So minus 9 plus 9 becomes 0. So it is minus 9 plus 9. So 9 4 is 36 minus 11 is 25. Minus 2 9s are minus 18 plus 3 is minus 15. 0 plus 1 is 1. 9 1s are 9 plus 0 is 9. Then after that I wanted to make minus 11 as this is operation number 4. Operation number 4. So it is 25. It is minus 11. Vice versa. You multiply this with 25, this with 11 and add negative. So then R2 is 25 R2 plus 11 R3. So you get 0 25 9s are 225 minus 11 25 plus 25 11s will be 0. Next 25 3s are 75 minus 165 minus 90. 25 plus 11 36. 0 plus 11 9s are 99. Just multiply and add. Then after that this one is 0. This is operation number 5. What is this? This is operation number 5. How to do operation number 5? Minus 2 and I have to take the help of diagonal element 25 only. Here also I took element to diagonal element 25. To make this element, I take the help of 9 only. See, I am taking the help of diagonal elements. I am using diagonal elements to make zeros only. I cannot take the help of, for example, this -1 I wanted to make as 0. I cannot take the help of this 3. Because if I take help of this 3, I may get 0, but this 0 also will be affected. Because this 1 and 0 will be added or subtracted. No? So now next operation to -2 to make a 0. This is operation number 5. So it is row 1 is 25 row 1 plus 2r3 because 25 2s are 25 2s are, that will come. So it is 25 1s are 25, 25 3s are 75 plus 0, this is 0. Next 25 minus 30 minus 5, 0 plus 2 2, 0 plus 18 18 because 9 2s are 18. Then next operation will be 75 with the help of 225. 3 into 75 is 225. So row 1 is 3r1 minus row 2. That's why don't need to do 225 row 1 minus like that, you don't need to do. So because 375 is a 225. So 3r1 minus r2. 325 is a 75. 225 minus 225 0, 0 minus 0 0. Then it is 3 5 minus 5 is minus 15 plus 90 75. 3 2 is 6 minus 36 minus 30. 3 18 is 54 minus 99 is minus 45. Now left side, you see the left side. Once look at the left side matrix. You got this, all zeros you got. Now this becomes ones. We need to make these are ones. How to make these are ones? See. So this is the way. If you see how to make those are ones, row 1 divided by 75, row 2 divided by 225, row 3 divided by 25. So that 1 0 0 0 1 0 0 0 1 will come. So divide and simplify and write all the answers. Then a matrix into A is equal to identity, means this is the inverse of A. A inverse is equal to this. So please try to understand how to apply the operations, row operations. Similar way you can do for column operations, but they don't mention the exams, final exams. Maximum they don't mention. If they mention, you try solving with column operations, but most priority will be given to the row operations. Maximum practice do by using row operations. Then 1 or 2 problems do by using column operations also. But 2 by 2 matrix means both row and column you do. So the question will be asked to find out the inverse of the matrix by using elementary operations. It is a 6-mark model for a 3 by 3 matrix. Try to understand. So that's all for today's session. Hope you understand everything. Thank you very much, everyone. So, and also some properties of the transpose. AB whole transpose will be written as B transpose into A transpose. The question will be asked to prove that, verify that AB whole transpose is equal to B transpose into A transpose. Also AB whole inverse is equal to B inverse into A inverse. In the textbook this proof will be explained. Proof is explained very carefully. Try to understand and prove it. AB whole inverse is equal to B inverse into A inverse. We cannot distribute A inverse into B inverse. AB whole inverse is equal to B inverse into A inverse. See these two properties also, let me stress, you need to remember these two properties also along with them. So hope you understand everything. Please try to refer my videos and try to subscribe my YouTube channel. I am K. Eswara Rao, PGT-MATH, working as a PGT-MATH in KV number 2, Port Blair. I will try to take more effective videos in future. There will be a change in making videos also. Due to net connectivity, I am giving less information nowadays. Not before, I did not give any videos. Due to net connectivity problems, I am giving very less information. After getting a proper network in my Port Blair, I am going to give a proper knowledge and very good effective classes. On board classes also I am going to give you. So you can join in my Zoom classes also. When I started network, when we started getting network, we do all these things. I try to work for you people. I try to work for the public. I will try to give you more knowledge, effective knowledge, and with this all things you will be benefited a lot. Thank you very much. Please try to subscribe my channel.